Hi guys, I'm Alex, and I wear many hats. One of the things I do is I'm a Mozilla Reps Council Member. That basically means I'm a volunteer who helps other people volunteer. But I do entertain the idea of a regular paycheck and a day job. So in my day job, I deal with Angular. I've dealt with Angular 1 for the past 3-4 years, and then we switched to Angular 2. And I'm going to talk today about the style guide. So how many of you do Angular 2? Let's see, show of hands. Quite a fair number. Do you guys know there's an official Angular 2 style guide? Okay, less and less. Cool, so I'm going to talk in serious terms like do, consider, and avoid. But you shouldn't take me that seriously. I mean, I've been known to have money strapped to my behind and dance on a table. The whole point of this is, whatever we talk here today, take with a pinch of salt, go home to your teams, and try to, judge it for yourselves. Don't just trust me on it. So the Angular style guide was created, the Angular 1 style guide was created by John Papa, who made the Angular 2 style guide as well. But with the Angular 2 style guide, the Angular team actually endorsed it, and it's on the official Angular documentation out there. It's split into several sort of chapters. Out of those, we're going to talk today only about a few, and that's because that's the ones me and my team decided to, actually follow. There's about 120 rules in the official style guide. It's a lot more than me can handle or remember or try to follow, at least consistently. So what we did, we went in there and we basically slashed at them based on experience with Angular 1, playing around with Angular 2, and so on and so forth. And we came up to around 40-ish that make sense to us. So we're going to talk about single responsibility, and when it comes to that, we only have a couple of rules. One of them is do define one thing, like a service or a component per file. And we try to limit ourselves to 400 lines of code. Now, you're going to see throughout my presentation green for do, blue for consider, and red for avoid. That basically means we try to do this. We're considering doing this on a case-by-case basis, and we do try our very best to avoid this kind of behavior because they're anti-patterns. Why we keep one thing in one file? That's because it makes it easier to read and maintain. And we used to have bugs when we combine components in the same file, and we shared variables or even worse things than that, like closures. We had unwanted closures and so on and so forth. This helped us fix a lot of bugs. And with the new TypeScript implementation for this, having just one file, just one thing per file automatically exports it. So that means we can lazy load it with the component router Jared was talking about earlier. The other stuff we do with single responsibilities, we keep small functions, roughly around 75 lines of code. That's because they're easier to test. When a function does only one thing and one thing, it's easier to test. And it's easier to read and maintain, and we do try to reuse them. When you have massive functions, you usually have variable pollution or external scopes, or again, unwanted closures, or dependencies coupling, which you can't really get rid of. So we try to keep things small. We have some naming conventions and some code conventions. When it comes to naming, we try to use consistent names for all symbols. That means we have a pattern that describes the symbol's feature and then its type. For example, hero list.component.typescript. And the only reason we do this is because it provides consistency for us. Consistency within a project is vital. Within a team is important, and within the company, it just makes it super efficient. So having a set of rules that work for you is, I think, in my opinion, important. We just choose to go with this one because we're super lazy, and well, the Angular CLI Tracy was talking about already does that for us, which is a nice thing. We use dashes to separate words in a descriptive name. And we try to stick to conventional types like service, component, pipe, module, and directive. Now, you could define your own. But in my experience, if you do that, something is horribly, horribly wrong with the way you structure your code. Again, we do this for the sake of consistency and quickly identify what's in a file without having to open it. You remember having Angular 1 files all within the other and having to open it up to see what it does? Well, this helps us a lot. And on top of that, our IDEs have fuzzy matching. That means we can search for our components within the IDE and so on and so forth. We have automated tasks that run on the files. And having dashes and dots as different kinds of separators helps us do easily pattern matching without having to be, regular expression gurus. We put our bootstrapping and platform logic for the app in a file called main.typescript. And we do avoid putting logic in the main TypeScript file. Instead, we usually use a component. I guess a service would be nice. But we use component because our architecture basically has one top-level shell and different apps which feed into the shell. So basically, each of our app fits inside the shell. This is an example of how it should look like or how our app module should look like. We have error handling inside of there. My pointer doesn't work, but that's fine. So this is how it should look like, imports and then just trying to bootstrap the module. The last Angular 1 app we worked with had a main file of about 1,000 lines. It wasn't easy to split, so we kind of learned from the mistakes of our past. We use lower camel case for naming the selectives in directives, and we use a custom prefix for all our components and directives. That's because we reuse a lot of what we do across apps, and when we put something on the internet, it kind of, like everyone who inspects our app knows it's our component out there. That's not the only reason. The Angular HTML parser is case sensitive and is going to recognize lower camel case. We use upper camel case when naming classes and interfaces, and lower camel case to name properties and methods. Now, I know this is going to be controversial, the next one, so just don't boo me off the stage. But we do constant variables in lower camel case. The first two we do because it's basically conventional thinking from other languages. And whenever we have something that indicates a constructible asset, we do upper camel case. The whole constant variable naming thing, I know you're used to doing something that's called upper snake case, but that's not easily readable for once. And the second thing is that comes from a time where IDEs weren't that popular or there at all. But now my IDE is able to show me I have a constant without it having to be upper snake case, whatever. And on top of that, like TypeScript itself won't allow me to do accidental reassignment of constants. So I'm gaining readability on top of that, and I don't have any drawback from my editor. We don't name interfaces without an I. So we don't name interfaces with an I prefix. Any of you here who used to do C or did C or do C right now or C++? Just a few of them. That's called, I guess, the Hungarian notation or something like that. We don't do it for a simple reason. The TypeScript guidelines discourage the I prefix. Some of us didn't do C or stuff like that, and we didn't understand why I was there. So if TypeScript said no, we just took it on faith. And we don't prefix private properties and methods with an underscore. That's basically because JavaScript doesn't really have private. Us putting an underscore in there just doesn't make sense. And on top of that, TypeScript has the private selector, so it's not a big deal. Underscore in front of it, you end up having underscore and stuff like that. It's confusing for us. When it comes to application structure, we try to follow the lift principles. And the lift principles say you should locate your code quickly, identify the code at a glance, keep the flattest structure we can, and try to be dry. Dry means don't repeat yourself. Now, there can be a thing as too dry, so it's kind of as it works for your team. The whole lift thing is in order of importance. So if you try to implement or use part of it, just go from top to bottom and stop whenever it feels too much for you. Why we adopted Lift is because Lift exists outside of Angular or outside of the JavaScript world. And for a bunch of our full stack devs, it makes it easier to understand, and it's consistent with what they're used to. When it comes to application structure in general, we have a couple of rules which are all consistent with the Lift guidelines. Some of them are common sense, some of them actually are black magic that just works after a while. Like keep a flat folder structure as long as possible. No one wants to go through 7 layers of folders just because when we engineered it, we over-engineered it. We usually create new folders when there's 7 or more files in it. The 7 or more files thing is actually not random, because 7 is a magic number. No, it's actually not random. So when you have a component, you have usually 4 files for it. The TypeScript, CSS, and HTML, and then a spec file, which is 4 files per component. When you have 2 components in the same file, that's too much. And we do try to do another thing. It doesn't usually work out for us, but we try. As each component has its separate folder, because otherwise it gets, as I said, a lot. And after 2 components, we kind of have to create a new folder and so on and so forth. And we're fans of the semantic approach. The semantic approach says that our folders are named by the features they represent and not by the type of the stuff in there. So our components folder, we don't have a components folder, actually. We have like a feature folder, let's say, a list folder and stuff like that, that basically says what's the feature and that's what the type of things in there. Now, today there was a talk about lazy loading components and stuff like that. We found out it helps that if you have lazy loaded stuff, they should be under the same folder, lazy loaded folder if you want. There's actually a notation that helps you identify lazy loaded folders, which is a plus or something like that in your app structure. We don't use that, we just put it under the same folder. The folder has a routing component, child components, and all the related assets. And it's making it easy for us to identify and isolate the feature content of the folder. We're going to talk a bit about components now. And we're using for components dash case or kebab case, which is kind of the same thing, for naming the element selectors. And we define our components as elements via selector. We do this for a simple reason. We keep hoping web elements or custom elements, it depends on the browser how you name them, are going to be a thing of the future, of the near future. So if that happens, we can switch our components to native browser elements easily. And that way, we're being consistent with HTML notation, which uses the same dash case for its elements. I know I told you each component has 4 files, and we put that separately and all that. But again, as the Angular style guide, we ourselves contradict ourselves in certain situations in the sense that if it's easier for us this way, we're going to do it this way. And that says if your template or your styles is just a couple of lines, we don't split it out in a different file. And we put presentation logic in the component class and not in the template, because that's easier to test. We don't actually have to render the template to see if our logic works. We place properties up top, followed by methods, and then we do private and then public members. Public and then private members. Alphabetized, that's just because it's easier to read and understand. If you don't do alphabetized in your work, just skip it. The whole beauty of this, as I'm trying to tell you, that the style guide or a style guide isn't set in stone. This is just the thing we use because it works for us. When it comes to directives, we use attribute directives when we have no presentation logic or we don't have a template. The whole idea is that we're being consistent with HTML, and by doing this, we can have multiple attributes or directive attributes on the same element. This is an example which just does mouse over, and that way we can have multiple things put on the same element, so multiple directives. If we would have the element directives, it's going to be nested and doesn't really work out for us. When it comes to services, we use singletons within the same injector. We use them for sharing data and functionality mostly. Services are ideal for sharing like stateful in-memory data or methods that we reuse across different components. And we try to keep them small, just the same as we do with functions. Like they have only one responsibility, which is encapsulated in the context. And once our service gets too big or does more than one thing, we try to split it out and have two separate services. We provide services to the Angular 2 injector at the topmost component where they'll be shared. And we do that because the Angular injector is hierarchical. And that means that if we do it at a top level, it's going to get shared through all the levels down. The same idea is if we do that and we have big services, the big service is going to get shared all the way down with multiple levels, and that means all the clutter is going to be there. That's why we try to do single responsibility. And we use the injectable class instead of the inject parameter. That has to do with the way both of them work. And injectable is just less verbose compared to using inject. That's the whole reason between them. Now you'd say services are just one type, or basically a super type, whatever. But we actually have to, we kind of define services as two different things. Services, and then we have something called data services, which is basically everything that has to do with data operations or interactive thing with data on an API or stuff like that. We abstract away. Ours are responsible for AJAX calls, local storage, stashing in memory, and basically any data operation. The reason we do that is components shouldn't know about your data. They should be just to interact with data, to get data and put it on the view. They shouldn't care about where the data comes from, and they should know only how the data looks like. Now, if you abstract all this away, whenever you need to refactor or, God forbid, even plug in a new service, with this abstraction, you can just change your data service without having to change every single data reference inside of your app. The last thing we'll look at are called lifecycle hooks. And we do implement the lifecycle hook interfaces. Those are ng-on init and stuff like that. The reason we do that is because we get strong typing for the method signatures. Our editor and usually the compiler can call our attention whenever we have a misspell or stuff like that. It makes our lives a lot easier. So I kept talking and talking and talking about the things we chose from the style guide. If you want to have a look at the style guide, it's at this address right there. I strongly encourage you to at least go through it once and see if it makes sense for you. At the end of it, you're going to see some tools that help you basically enforce it, like Codealyzer and snippets for your editor. We use Visual Studio Code. Now, this is a lot. And we tried Codealyzer for a while, but it basically lengthened our pull request process from inside a day to about 3 days. We kind of decided to drop it, and we're doing our own thing. Codealyzer can be edited for just your own rules. Now, out of the rules we have, we're cheating a bit. We're using the Angular CLI, which kind of takes care of about 60% of things for us. The rules we chose are also in the CLI. Tracy talked about the CLI today. Do give it a try. It's that easy to create an app. And with that, I thank you. Or as the organizers told me, you should say, dziękuję. I'm really hoping that means thank you.